Hi, welcome to my channel. I'm Mr. Delovit. Today, we'll be looking at Cameroon GCE, June 2023, question 4b. But before we dive into the question, I wish you to press the video and highlight or bring out the keywords that will enable us to answer this question on question 4b. Okay, I know you have pressed the video and you have highlighted the main words. So first thing we have the main words here. We have we have this one, sketch your graph. We have mechanical energy. We have displacement from the rest position. Yeah, and we have the last one, put to a further distance of 4.8 centimeters. You have all this correct. Give a tap on your bag that I did it. That yay, I'm going to the point. Great. Now we are going to go dive into the question, but before, let me draw the graph, the, the the diagram to this question. So the diagram, so the diagram to this question, it's like this. Now, so that how diagram looks like. Now we have, try to bring it down. So you have this one, this key equation, okay, and so we have to draw the graph. So to have this, now so that's a graph that we used to draw. That is the diagram of this equation. So for us to draw, to sketch a graph of mechanical energy, so one thing we need to sketch. So you don't need to go all details, but you need to get some main points. So before we do the sketch, we have to know that mechanical energy is same as is equals to total the potential energy plus kinetic energy. And we know kinetic potential energy is equal to half kx squared, and kinetic energy is half m omega squared into a squared minus x squared. So that's that. So we are plotting the graph of energy against x, which is the displacement. So if you combine these two equations, if you take this potential energy and add to that and put into the formula above, you have half kx squared plus half m omega squared a squared minus x squared. Now, having this, now means we are plotting ET against x. So we have to look for some key points to help us sketch. So we say, okay, at x equal to 0, what happens to this formula? You see this man becomes 0, and this man also becomes 0. So we have ET will be equal to half m omega squared a squared, which is same as half k a squared, which is same as the maximum kinetic energy, because k is also same as m omega squared. That's why we say k half a km squared. Now, when x equal to a, and the amplitude here is same as 4.8 centimeters. That's why we said from this equation, when you put through a distance of 4.8 centimeters, it means that from this here, we have this, and we have this. So when you put a ruler here, and if this is the equilibrium position, so it moves down minus 4.8 centimeters, and it moves up minus 4.8, a positive 4.8 centimeters. If we take our up direction positive and down direction negative, so we have this. So that's what the diagram they're explaining the diagram in the equation. So if you have x equals that, so if you put x equals to a into this equation, if you put into this equation here, so you see that ET will be equal to half KA squared, because this man also is constant. And you see that it's the same as the kinetic potential energy maximum. Maximum potential energy. Now, if you add that two equations, if you just add this, if we expand this equation, like for example, we say half kx squared plus half mw squared a squared minus half mw squared x squared. So we see that we add these two, this man, okay, let's go down. So ET will equal to half kx squared plus half ka squared minus half kx squared, sorry. So because this man mw squared, this one is same as k. So in this case, this man takes care of this. So if I have a formula, it becomes back ET equals to half k a squared. So you see that this equation, this equation here is 3, let's say 3, 2, and 1. If you look at these three, all are the same. So it means that this mechanical energy is independent of the displacement. So how do we sketch the graph right now? If you do the calculations here, you see that half k is 150.8 from the previous video times the amplitude, which is 4.8 times 10 to the minus 2 meters, all squared. So if you do all this, your answer will be 0.17 joules. So if you do this, now you see that to plot this graph, let's say this is our axis, this E, those joules, and we have displacement. Now say when x is 0, this is 0 here, which is the equilibrium position, our value there is 0 point, because the value here, this value we have here, will be the same at 2 and will be the same at 1, because we have the same formula. If you look at the formula, all are the same. So it means that if this is 0 point, it will be 0.17. Then here we have 0.048, and here we have minus 0.048, because those are the amplitude. This is the equilibrium position. So it means that when x is 0, what happens to the ET? ET is the same value. Is here. Now when x is 0.048, we still have the same value. When x is minus 0.048, we still have the same value. So it means that our graph will be a straight line like that. So this is how the graph looks like. A graph of ET against that. Okay, thank you so much for watching. But we know that, but before I want to take a hint before I close it, you know that potential energy will be like this, and the kinetic energy will be like that. But they ask us to plot the graph of ET, of E, and mechanical energy against displacement. Okay, thank you. Thank you for watching, and stay tuned for more videos.